All right. Okay, all right, so great. All right, so I'm going to talk about libswak++. This is a project that I spun off Traffic Server. This is a solid wall of code. Microphone. Okay, so this is libswak. You didn't say use it correctly, but we're engineers, be specific. This is a project I split off from Traffic Server, solid wall of code, C++. It's a library that's based on pieces that are all in Traffic Server, but like, I was thinking about the quick guys when I was going on about doing this. And so this is splitting this off is let me do this much faster turnaround time. It's in a separate repo. Again, it's public. If you go to my GitHub profile, you can find the repository. So this is basically a large collection of utilities. They're variants of all the ATS stuff. These are much better in terms of code quality and documentation because I've been able to iterate it a lot more. I've used it in 3 or 4 other side projects to get it more usable and appropriate. So yes, I do have other projects besides ATS that I am working on. And I also was designing this for use in ATS plugins. It is possible, what we may want to do for the core is bring this in as a separate library rather than having it directly integrated. So what do we have in here? A couple of cool classes. So MemSpan is like a string view, except it's about writable memory. It's gone through a few iterations. I like the way it works now. It's kind of similar to stuff that's going to be coming out in C++20 again, because I've been influenced by their design. So this is basically to be used in places where you're passing in buffers around. You want to say, I have this buffer rather than, again, like string view, passing a pointer and a length. You can pass a MemSpan. It makes casting easy when we do aliasing. So it's kind of like a dynamic array in that sense. Whoops, let's go the wrong way. So this is one of the bigger ones. MemArena is a replacement for what's currently called Arena, arena.h in Traffic Server, except it's enormously better, in no small part because it uses C++ 11t mechanisms. It's basically the standard memory arena. I have a lot of small allocations. I want to amortize that cost by doing larger allocations and handing out pieces. It's heap-based, so although it has some basic support for generational garbage collection, it's really designed to say I'm going to allocate a bunch of stuff, and then at some point in the future, I'm just going to get rid of it all. So example would be, of course, headers in a transaction. We allocate them as we go. We keep them around. When the transaction ends, we just drop it. So this also amortizes your cleanup costs, right? Because now you don't go and clean up all the little pieces. You just drop the entire arena, and off it goes. It also, I added this feature in because this is actually used in the code in Traffic Server is to do a temporary allocation. So you can tell the MemArena, make sure that you have at least n bytes of allocatable space, and then give me a MemSpan on it. And then I'll just use that and then move on. So that way, if you have a bunch of temporary places you need to work with that are variable length, you can amortize the cost of those as well. And that's actually used inside Traffic Server. Another class I've been using heavily is Errata. So His Royal Peachiness at one point added this return class to Traffic Server that kind of snuck in using return values. Errata is about returning more useful error messages. So key things is if you're successful, it's extremely fast. It just initializes the null pointer. You can stack messages up. You can put severities on them. There's another mechanism with it that you can say, well, I want to return a value plus potential error conditions. And we can also put in what are called sinks to say, well, if an errata goes out of scope and nobody logged it, just go ahead and log it for me. So I've been using this very heavily in the YAML stuff to provide better diagnostics, because if something returns an errata with the message, you can add another message on that that provides additional context. So in that case, it's kind of like a stack unwind or the Java exceptions, rather than actually doing exception processing, which is generally frowned upon here. So been improving that. Of course, TextView, which Leif always hassles me about, but I find too useful to give up. So TextView originally, okay, so yeah, Stephen ran into a problem with const buffer, which is a very early effort in this regard. It's gone through a couple iterations. I actually wrote my own string view, and then we discovered that C++ 17 had that as well. So we switched over to that, and TextView became a subclass of this. So what this does is really about parsing the contents of the string. So if it's just a block of text you're passing around, TextView has no advantages. Just use the string view. It's more compatible. TextView is when you've got a piece of text and you want to look inside of it and parse it. Right? If you're tempted to use string toke, don't. It's wrong. TextView does everything string toke does except faster and better. It doesn't require any additional allocations. It doesn't require modifying the original source. It's designed to be able to use in a streaming way where you can put a text view on your thing and then pick off the pieces iteratively until you get to the end, never doing allocations. I really like the string list thing. I hate that because it allocates a vector to do all of that parsing. No allocations. You can parse entire files with a single allocation to read the content in. And that's how I do, like if you look at the IP allow support, that's how it parses the IP allow. It allocates a chunk of memory, it reads the entire file into it in one shot, and then parses that. No further allocations. Let's see. So this is another fun one that I've gotten flack about, but I can't give up because it's me and I'm always cool. So BufferWriter formatting, we started with BufferWriter to do, well, write to buffers. We do a lot of fixed buffer writing stuff inside Traffic Server. And it was all generally hand-rolled checking the size. So you add something, you do a mem copy, you check the size, increment the size, checks if it's too big, do a mem copy, check the size. BufferWriter automates all of that, right? And again, that's my philosophy. I saw the same code being written over and over and over and said, why don't we have a class that just does that for you? So BufferWriter lets you just write to the buffer, and if it runs out of space, it just stops writing. And it tracks how much you would have needed. So it's very easy to do like 2-pass allocations where you just say, well, it's probably this is big enough. I'll do it. If it's not big enough, I can actually do an allocation, get enough space, and then do it again. And you don't have to do, it does all the tracking, so you can just say write, and it won't overflow. So it's safer that way. Once we did that, I wanted to do better formatting so I could write text, formatted text into these buffers, and that eventually evolved into BufferWriter formatting. I don't know if anyone has seen this in there. It's Python based, so it looks a lot like Python formatting. Has anyone here coded in Python? Okay, so if you've done formatted output in Python, it takes you about 2 minutes to learn BufferWriter formatting. I tried to be as similar as possible. If you look at this link here, they are going to a standard format, which is extremely similar to this. They also base their stuff on Python. So this is the direction that the C++ community is going. The Python stuff, it was good enough, it was mature, it was well-defined, it made a nice basis for doing this stuff. So I'm not surprised that they made the same choice. When you look around and see what people are doing, that was just what was happening. So I don't know if I have, hello, oh, there we go. Is that it? Wow, that's the end of my slides. So one of the nice things like a BufferWriter formatting is it uses variadic templates internally. You don't have to know that the implementation of what it means is that when you pass an object to the printf, I know what type it is. The printf knows the type. You can then simply pick the correct formatter to do the output. You don't have to worry about %d or %s or %.*s or any of that stuff. It knows the type. It does the right thing. So I probably should have gotten some examples. So the basic unit is open brace, open curly, close curly instead of % something. So you can do every single thing in an entire printf of this with just open curly for every single thing you want to put in. That's it. You're done. It's extensible, so if you have a new type that you'd like to print, you can write a formatter that says, oh, if you're trying to print this type, here's how you do it. And you can do that once. And then it's just usable. So this is really great. Where I use it is for enums. So you can write a formatter for enum, so if you pass an enum, you get the string. You don't have to remember what magic function calls or anything. It's an open curly, close curly. That's it. It has all the standard formatting stuff, so you can do fixed width, you can do hexadecimal, blah, blah, blah. I've got a bunch of utilities attached to this that let you do things like conditional strings to say, well, here's a list of three strings. Whichever one is non-null and non-empty first, use that one. So instead of doing these complicated ifs or ternary operators inside your printfs, you can just say, well, first of string, 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 string. And whichever is the first valid string, that gets printed. So, you know, if you're getting input and it might be null or something, you can pass that and then put a constant after it, and off you go. There's hex dump support. So you can say, here's an object, dump the hex for it, and it just dumps that. So anyway, I just thought you should know about that. If you want to look at that for plugins, again, it's under the Apache license, blah, blah, blah. So that's about it. There's actually a bunch of other classes in there. Ooh, I know what I want to do. Let's see. Yeah, so here's some documentation on it. There's some example code down here. Right, so here's what it looks like. Brace, curly, curly, space, curly. And there's like for instance, here's a nice one that I use, which I like, is Errata. So I take an Errata and I wrap it in this class, and then BufferWriter knows, oh, it's an integer, but he wants to format it as an Errata. So I'll go and look up all the string Errata stuff and all that cruft for you and just do it. All right. Right, so you have Errata, you have date. Actually, one of the biggest uses of this is for IP addresses. So I have a complete set of IP address formatting in here. So you none of that ATS, IP, P to N, and all that stuff. You just say open brace, close brace, pass it the IP address. Writing a format class. Let's see if I can find the IP address stuff in here. Yeah, what? Printing an enum?
So you said we can extend this with process that we don't need
Yeah. Yeah, I'm trying to find that here. Okay. Yeah, this is an example where I put a special parser in so you can use printf style formats with BufferWriter. So it's flexible enough that I can just change that. It's also got a feature where you can have, I'll get to yours in a sec. It has a feature with context, so you can say, whenever you're doing the formatting, if the thing has a name, look it up here and print that instead. That's actually a feature I've been using more heavily. Where is that? Sorry, too much documentation. I know that's not a... Yeah, no, that's not. Oh, sorry. Where is this? Oh, so one of the name things you can do is, I know that one of the masses, was it you, Masur? I thought you fiddled with this. So you can just say brace timestamp brace, and it goes and formats up timestamp for you. Timestamp, global names, external generators, name binding. All right. Golly. Yeah. Format classes. So, no, you don't actually need a format class, specific types. All right. Oh, here we go. No, that's argument forwarding. So you can actually override this. You can use your own argument formatting. This is heavily used by Errata. Oh, here we go. This is an example. So here we say, okay, we've got this HTTP transact server state type here, which is an enum. So I write this code here that says, okay, well, I overload BW format where it takes a BufferWriter and a format specifier and this type. And then if you pass this type to print, it'll call this function. Okay, and the function is handed the output BufferWriter and the format specifier. So you can look at those if you want. and then it generates output on the specifiers. So what this says is if you gave me a numeric type like D or something, I'm going to print the numeric value of the enum. But if you didn't, then I'm going to print the string. And that's it. So, and then we call, this already exists here. So it says, well, if I need the name, I'm just going to call this. But the key point is that then only the person who writes this needs to know this magic bit here. For everyone else, they just pass it, and it just works. So this prints what you'd expect. That's what it looks like when you use it.
So we still need the HTTP developer name for the same name, so developer function.
Get him a mic. Yeah, so you can do this for a bunch of classes. Now, sadly, the one part that's kind of annoying, but I don't know how to, there's no good way around, is you have to put this in a file somewhere, and you have to include that.
Okay, so but the user don't need to care about
Yeah. Yeah, one person once writes this, and then everyone else does that.
Okay, got it.
Anyway, all right, well, that's pretty much about it. If anyone wants to look, there's a bunch of other classes in, yeah, that's the list of classes here. Meta, MemSpan, TextView, intrusive DList, intrusive hash map, look at those. Scalar, which is kind of fun. And some meta programming, some very simple meta programming stuff. So yeah, so I'd like to consider having this, be able to keep the velocity one, I'd like to consider bringing this in as a third party like we do YAML CPP, where I publish libswak as a separate repo, and then we just copy it in as a specific release. Any questions? All right, let's go on to the next talk, because you can never get enough of me. Let's see, go away. What was the next one? I was going to talk about CWiki. Leif, wake up.
I'm looking at schedule.
What's the next talk? The CWiki one?
I'm looking at that. It's taking a while. I had to reboot my computer.
I think that's what it is.
You fix BufferWriter?
Can I fix it?
Yeah.
It's perfect.
I'll show you. Tell me where it's wrong.
Well, bug me after. Let me give a talk here first. There's actually a conference going on.
We're waiting for
It's coming up in a minute.
Oh yeah, here's the, this is the ISO standard one. I'm not going to explain it because I put the link in, so you can just go look this up.
Can you show me an example of the ISOs?
Golly. Let's see, what about this?
It's like going so slow.
Yeah, so this is what standard format would look like in the C++20 thing. The same curly braces, you pass the arguments, it does the same sort of variadic template implementation.
what's the format there? Is that a
Standard format, that's what this document's about. So this is proposed as part of the C++20 standard to do string formatting.
should we rename ours as standard format or
There was an argument about that. I would rather, I eventually agreed with Brian that we should have a distinct name so it's clear what you're using.
the goal should be that we get to here.
Possibly. I'm still reviewing what actually they have. I think we're probably going to end up something like the TextView thing where there's a number of features that I need that they're not putting in. But we'll be backwards compatible so that anything that works with standard format will work with BufferWriter. BufferWriter is also designed much more around fixed-sized buffers too. So this is kind of designed around stream I/O, and then they have some performance things to help you with fixed buffer writing. I think they should have fixed the stream stuff because For some reason, which I don't understand, the stream stuff makes it very difficult to just say, hey, I've got this buffer here, why don't you use that?
Well, they have that, but then they got away from it because,
It was unsafe?
well, yeah, it was unsafe because you got a pointer into it and then it reallocated memory and moved to someplace else. That's,
Yeah,
that's the whole third stream.
oh, yeah, Surstream. Yeah, I looked at that early on when I was working on this, and I was looking at that, and then I saw, oh, deprecated, going away. I said, well, probably shouldn't use that.
That has been deprecated for a long time.
Anyway, so what was next?
CWiki.
All right. So this is something that's come up. I am 100% in favor of this, moving everything we can from the wiki to Sphinx, unify our documentation resources. What do we got?
Well, I think stuff that doesn't change, right?
It's what?
Things that are more static.
Yeah, I'll get to that. Why we want to do this, people never update the wiki. I actually saw something for ATS 2 removed within the last year. I find the wiki editing extremely painful and way more difficult than editing a text file. To edit, you have to have an ASF login and support, and we have to give you credentials. And people never really look there. So what we do is, as Brian said, we look at stuff that's long-term, that's stable, and we move that content over to Sphinx and publish it. This is an additional burden. You already have to have Sphinx to build the docs. It's easier for the ulterior to help us because all you need is a GitHub account. You set up a PR, and off we go. You build the documentation. Yum and DNF are enough to get everything you need to build the documentation. So no custom building, nothing of that sort. You can actually review the changes before you publish it. So when people do updates, we can proactively review them rather than having them update the wiki and then decide, oh, we shouldn't have published that. So how do we actually do that? So there's the various wiki parts. Now, I encourage people to jump in. If you have any comments, Miles, about the wiki and the documentation, this is the time to speak up. So the design docs, I can go ahead and take care of that because frankly, if you look at it, there's like 3 pages. I mean, it's just, there's almost nothing there. There's 4 plugins documented there. All of those, I think, should be moved over to the Sphinx docs because that's where all the other plugins are documented. Someone else is going to have to look at doing those. The FAQ is pathetic. It's 1.5 pages, maybe. It's tiny. That should be moved. All the contributing stuff, again, one of the things is when I look through this, there's not all that much context. If there's 20 total pages here, I'd be surprised. So we should move that over because we already have stuff about this. I know John Symes put in stuff about how to do the builds. This should just be either integrated that or put something place similar.
Are you talking about merging the CWiki into docs?
No, what I'm saying is
Making a separate CWiki in Sphinx?
yeah, a separate CWiki and Sphinx, and segregate this stuff to say, so we'd leave some stuff in the wiki.
Is it worth maintaining a separate CWiki?
I believe so for certain types of content. So that's what I'm going to get to here.
Okay.
I think basically the one things I would keep in the wiki is this. Right? People already looked there. It's more transient. So basically, at the end of this, if it did it this way, this would be what's in the wiki, period. Everything else will move. And there's just not that much other stuff. Installation configuration. This one actually has some substance to it. But again, we have this stuff in the docs. And really, people, when they get a product like this, they don't look in a wiki for how to install it. They say, here's the docs, right?
I think we can probably define a little more precise than that. Maybe something like if it's code related or anything related to the tracking server, the software itself, it goes into docs. If it's community related, such as events and presentations and those sort of things, then it goes into
The wiki.
to the wiki.
All right, that sounds fine with me.
But then where does the building pages?
That goes into docs.
Because that's about the software.
It stays pretty consistent.
I'm fine with that. To say if it's about the software, it's in Sphinx. If it's about the community, it's in the wiki.
That's one.
So we have to move all this stuff. People are going to have to step up and move some of this stuff. But what's new? Now, Leif had some thoughts on this in particular. So if we do this, Leif points out, then this can be part of the PR. It's not like you put it in and then you do, hopefully, going right up to the wiki. We can actually say, no, that PR is not going in until I see an update in the what's new. Right? Or I see some other documentation. So when we do changes to the software, all the other pieces that we might want updated, all the documentation and build instruction, all of that, can be part of the same PR. We can make sure it all comes up in one shot.
Is this particular for the release notes and upgrading to notes?
Yes. So
really hard to keep in sync with what's happening.
and it's just easier for you too, because if you're doing this change, you know right then what's new, what needs to be upgraded, and it's just easier for everybody if you just put that in the PR and say, well, there it is, right? And people can say, oh, wait, you have to do that to upgrade? Far better than committing it and discovering a week before we release, oh, you really can't do that kind of upgrade, that's not possible.
Are you going to move CWiki or the proposal to move CWiki into the repo?
Yes,
As Docs is now.
We're not removing anything.
We have to rewrite it.
Yeah.
We have to rewrite it.
Oh, I'm sorry. I meant the scope of the content.
Right.
Can
The
you not
content gets moved into.
and it gets written in Sphinx,
So
and
okay, that was a little bit confused. We're talking about PRs. You can't have a PR reference to the repo, so it'll have to be in the
yeah, so everything that's moved over is moved over to Sphinx, built the same way as all the other docs. It's just part of the Sphinx documentation, exactly the same way everything else is.
On the docs of Travis or Apache.
Yes, now we're going to have a talk at some point about reorg in there. I know I talked to Miles a bit about, I don't like the way the architecture section has evolved. It's livable, but Lord, it's not good. So that needs to be done. We need to discuss where exactly this stuff. So at some point we're going to have a serious discussion about restructuring that and making it more coherent and appropriate. It's becoming a bit of a mess. Again, it's not a big mess yet, but it's heading that direction. We should fix it now when it's easy.
Yes, I think before we move anything, we need to have Miles and Alan agree on what the structure should be like, such that we don't get Steven's structure and Jan's structure and Masakazu's structure, and then it's one of these dumpster fires again, right?
Yeah, we need that needs to be more regularized and formatted, and then documented in Sphinx. Because that would actually be appropriate to put under the that whole doc section, right? How the doc's structured that Symes put in. We can put it all there and say this is where the various pieces are supposed to go and how they're supposed to fit together. Let's see, what else do we have? Upgrading development process. So the projects, that was a more interesting one. So there's a set of projects. Of course, these are all hideously out of date. Lack of maintenance. So we have to decide whether we want to keep these in the wiki, you want to move them to the GitHub projects, you want to move them to Sphinx.
GitHub projects.
You think that's where all that stuff should go? I'm fine with that. The wiki is clearly not working.
That's what VJ and Rushford were doing for Parent, right? And I think Masakazu, Masori, VJ isn't paying attention at all. Masori, Masakazu, you guys used the project too for the Quick project, right? Right, to track the PRs and track the issues and that sort of stuff. I totally think that's the right way to do it.
I'm fine with that.
We cannot put any documentation in this project.
Right. But can we use the...
Now, one problem is that only committers can update project pages.
Can we do gists or whatever they're called on our GitHub, or is that restricted?
I do not know.
Well, so our GitHub is not the same as everyone else's GitHub because it's managed by Apache, the foundation. The gist thing, that's where you can put in sort of like documents and like random pages and whatnot. It's kind of like a wiki on its own.
Well, it's like apace.info is what it's most like.
Well, yeah, something, but that would be an option where we could put project-related stuff into gists and then link to that from the issue or the PR or whatever it might be, right?
All right.
But other than that, we're going to have to document the the work being done has to be documented in the PRs and the issues themselves until they become part of the project when they actually landed, and then they get moved into docs if they need documentation there.
Yeah, I'm fine with that. Yeah, I made a note.
But it does get problematic, though, like you said, like you're doing quick design documents. Where the hell do you put those? Stuff that hasn't been coded up yet, right?
Yes. I put that on my own GitHub pages.
I think we should look into this, if we can get these the GitHub version of Wiki, the gist stuff. Is that what they call it, gist? Or something else?
Different things. GIFs are like places to put a code snippet or a small document.
Right.
You can also have wiki, that's a whole separate thing on GitHub.
Okay.
And you have GitHub Pages, which is a whole separate thing.
Well, maybe one of those could be used for these sort of design documents as they being worked on.
Yeah. So I want to talk about some additional tools to make sure people are aware of them. These are some of the things I like about Sphinx, why I want to move some of this stuff. Sphinx has this literal include thing, so you can say, here's a file. Go include these lines from it directly into my documentation in a block quote. Okay, and this is really cool. So let's see if I can, so like the BufferWriter formatting. So like this is actual code that's coming out of a C file. This is not directly in the documentation itself. Or this one here. This is what I was looking for before. This is an example of the kind of IP address formatting you can do with BufferWriter. Anyway, but this is actually coming out of a C file. And one of the things I've done with this project that I'd like to consider here, so I better not get Stephen upset with me. So this is from libswak. This is the repo here. And you'll see that it, of course, uses catch like we do, because catch rocks. So you see you have a test BufferWriter here, which is a standard unit test file, right? Over here we have exbw format. This is run as a unit test, but it exists in order to include into my documentation. So that way I know my documentation examples not only compile, but they run correctly. So every time I do a build and run the unit test, it tests all of my example code. That rocks. So that when I change things and my examples don't build anymore, the unit test tells me, hey, this doesn't work. Your example is wrong. So that's really powerful. And that comes back to something Stephen asked earlier when we talked about example files. That's what I like to do. So you put an example file in, and then in the docs, you can reach over and you can pull pieces of that in and say, here's the piece from the file. So they don't have to, how can I express this? That way they don't have to assemble the file from the documentation. They can just grab the file. But then when I look at it then, and it keeps it in sync because you're pulling directly from that. So that's really cool. Right. So it is absolutely, this is more work. This is significantly more work than what we do now. I think it's completely worth it because, yes, for exactly that reason, I know my examples build. I know my examples run and run correctly because I have unit tests on those examples. So GitHub Pages, we talked about this. Do I have an example up here? Where is that? Text formatting, Spring Summit. Okay, so here's the website. If you guys want to see this locally, you can go to solidwallofcode.com and it'll send you here. This is GitHub Pages. So I have repo A, in which this is all checked in as Sphinx source code. And then I have repo B, which is GitHub Pages. And I have a script that says, go to repo A, build the docs, put them in repo B, and publish. So I write my stuff in Sphinx. Now you'll notice that this is fast enough that here's the notes from yesterday and today that I was typing up this morning. You hear me typing away. This is what I was typing. And I've already typed it up, published it, and it's out on the web. Anyway, so I mean, other people said Sphinx. This is how easy I find Sphinx to work with, but it may just be that I'm weird. But it's just easier. Get all this stuff over here, blah, blah, blah. And it's just that fast. We also selected PlantUML as our diagramming tool. And this came up earlier with the OmniGraph and whatever. So PlantUML is this Java thing. It takes a text format and generates UML and related diagrams. I like the text base for these reasons here, right? Once you do this kind of stuff, it's really, really great. So if I have 5 similar diagrams, I write one, I cut and paste it, I tweak it a bit, I got my second diagram. It's public, so we can just download it. If you actually build the docs on Traffic Server, it actually downloads this from bin tray. And what's really cool is if you use a real editor, like CLion or Visual Code, there's integration tools, and it will actually generate that in semi-real time, and you can see the output. So that is, when you're working with it and trying to get diagrams right, that's really rocks. In the current documentation set, you can do it. You can do it inline directly. You can do it as a separate file. Both of those work depending on which you find more convenient. So that's really nice. So here's a diagram. This is actually in our documentation right now for the TLS Bridge plugin. This is an example. So this documents how the TLS Bridge does communication when it's talking, right? It looks nice, doesn't it? It's clear. You can understand. You can see what's going on here. This is the code. This is the actual source that generates that picture. Not very big. And if you wanted to make a similar picture, you could just copy that file and tweak it. Now this is a more experimental thing that I'm working on. This is not ready for prime time yet, but I'm getting close. Doxygen integration into the Sphinx. So what does this actually mean? So here's a clip from the libswak documentation, and you see the rebind method here is a link. And what I've done inside and if you click that link, it takes you to a Doxygen generation of libswak. So libswak has Doxygen set up. I generate Doxygen pages. When you click the rebind method, it takes you directly here for the reference. And so basically what you do is you can just say, what this actually looks like in the original source is :libswak : back quote, MemSpan : rebind. And it goes and it looks up the method for you and generates the link. You have to give it the root. All you really have to give it is the root of the external documentation, and it does all these linking for you. So you can have these really nice links to reference documentation. Do I have that? Right. Let's see if I can find one here. You see a method somewhere here? Oh, of course. Oh, no. All right, so like for instance, I have a class now. So this is one of the things that really bugged me with the current stuff we have in traffic servers. If I have a class like this, I have to write all this Sphinx documentation here, and then I have to put it in the Doxygen comments too. But for libswak, I don't. I just put that link there, and I can just have a simple link over here. Here's the Doxygen for it. Anyway, all right. Well, that's about it. Is there any other comments, questions, critiques, wild adulation? It doesn't hurt to ask. No, I'm really quite happy with Sphinx. I mean, obviously, like everything, it has some issues, but basically, and it's actively developed. I think this is the way to go. I think we can make our documentation much better. And golly, I don't like to harp on this too much, but when we're trying to attract people to use our stuff, when we're trying to attract developers, and we're trying to get the community to grow and get better use, people see the documentation. I mean, there's no shortage of projects I've looked at and said, well, that looks cool. I look at the docs and say, nothing's documented here, and I just move on, right? It's hard for me to say. I use decked out hardware, so for me it takes about 45, 60 seconds. we've made a lot of improvement. A lot. Python 3. If you have Python 3, you're good. Yes, but there should be a list on the website in the Sphinx docs that say, here are the modules you need. It's like, there's only like 3 or 4. Okay, there's Sphinx, there's the PlantUML contrib, there's the read the docs format, and I think that's about it. If it's not, I'll update again. But yes, one of the things, I know that was a problem, and we've done a lot of work to make it easier and easier, because you do not have as many problems as Susan has had getting this to work. And let me say, you cannot motivate me like Susan does to get this to work. So, and I'm not the only one, though. I know that Miles has helped out, and I think, God, someone else was helping with us, too. I don't remember, not someone who's regularly here, but he put a bunch of PRs up to help fix some of this stuff. But one of the things we did do in this regard is we took the official advice, and we said, no more Python 2. Right? That was the Python community said, Python 2 is dead, move on. So we did. So now, for Sphinx and all of this stuff, Python 3 is required, that's it. You run Python 3. Full stop. So yeah, that's much better. Or I can show you over here. We can look at it there. I've got it running there. Well, it's a Mac though. Well, does Mac have DNF or Yum, or how do you? All right, Leif will make it happen. Should what? Yeah, you can pick everything you need. Everything you need for it. Yeah, everything you need should be pippable. That's how I put stuff in. And there's an automatic download with the PlantUML jar. We put it in bin tray just like the Clang format. It works the same way. So the first time you build the docs, it'll go to bin tray and download the PlantUML jar. So that's a one-time thing. So don't be shocked when that happens. Anyway, so yeah, so I think we need to look at, I would really like to look at doing the Doxygen stuff for traffic server.
I think the next step is that we figure out how we want to organize this.
Yes, we need to do that, yes. All right. Let me make a note.
There was 11 Sphinx modules installed.
11?
Yes, when you install some of the output, it goes in other Sphinx.
Yeah, but frankly, I don't care about that. What matters...
Which one is which, because you never see which 11 there is.
All right, I'll go find my list, because we want the minimal list, right? We don't care what else is installed. We want to say when someone wants to build this, here's a list, the smallest possible list of pip things. Install those, and then it works.
I have a question about BufferWriter.
Yes.
Are we supposed to use BufferWriter instead of SPF?
That's a hard question. I would, at this point, probably not. The BufferWriter in traffic server is not at the quality I would like. The one in libswak is. So that's one of the reasons I'd like to do a library import of that, treat it like YAML CPP. But you can, and we actually do that quite a bit. It's a little harder to use for printf, because you have to take the buffer, and then you have to and you have to send the view out to, for SNPrintf, yes. No, actually, I'd tend to use it for SNPrintf. Especially local BufferWriter, have you used that? So local BufferWriter is a subclass where you can, as a template argument, say, I need n bytes of static storage, of local storage, and then it just creates that for you and manages it. And then you can get a string view out. So yeah, actually for SNPrintf, I'd recommend using BufferWriter. If you have any problems, bug me. One of the things we do need to do is do better about getting some of the supporting formatters together so that it's easier to use. But I think it works great for that. Wait, if you see SN printf, oh, so you want to be able to, oh, I'm not sure we're going to go that far. I would like to, sometime later this summer or the fall, look at fixing up the debug and logging stuff to be BufferWriter style, or have a parallel one that's BufferWriter style, to make that a lot easier and encourage people to do better and faster logging. We can in fact get some small performance improvements from that because we can only evaluate arguments if they're actually logging, right? So if you do right now, if you say are printing 3 or 4 IP addresses, you do the conversion and then you decide if you're going to actually log it based on the debug tag, right? If you use a BufferWriter, then you do that after you decide you're going to log it. So if you don't log it, you don't do those string conversions. So that's a somewhat faster. You'll see, and then some places there's code to say if debug tag set, then do this when it's really expensive. But I'd like to get around that. I'd like the BufferWriter and the logging stuff to just take care of that for you and say, well, if I'm not logging, everything's passed by reference, so there's no, the stat costs are very small. So, all right. Anything else? All right. What was the next? What were we going to hack on now? Okay.